everyone, I'm Arthi. I'm a Principal Research Manager at Microsoft. During my undergraduate days as a computer science major, I was introduced to this field of human factors and ergonomics. The field, for those who are unaware, it's really one where you draw from various disciplines like psychology, anthropometry, interaction design, biomechanics, sociology, visual design, etc., with the end goal of reducing human error, increasing productivity, and enhancing safety. I was really drawn to this field because there has been in history a disturbing share of technological disasters caused by incompatibilities between the way products are designed and the way users actually perceive, think, and act. These disasters can be catastrophic when it occurs in a cockpit, in a nuclear reactor, or in an operating room. Oftentimes, the blame is placed on the human operator, while the fault actually lies in pure system integration, or in other words, the system is not engineered to match the capabilities and limitations of its users. And that's what I wanted to study. So I pursued a PhD in the field, and I've had several amazing role models whose work I've been inspired by: the late Dr. Raja Parashuraman, Dr. Christopher Wickens, my own advisor, Dr. Frank Durso, to name a few. I worked on several human factors issues in aviation during graduate school and later on in healthcare. Again, my goal was to make these domains safer and more effective. A role at Microsoft exploring the impact of emerging technologies on people was a natural career progression for me because I felt that I have the ability to impact the lives of so many people in positive ways. After completing my undergrad in computer science from India, I worked in Siemens India as a systems engineer. I've always wanted to move to the United States to pursue graduate education. So less than 2 years into working at Siemens, I moved to Lubbock, Texas to pursue my PhD in experimental psychology with a specialization in human factors ergonomics from Texas Tech University. Graduate school, I have to say, was really transformative. Here I learned a lot of core skills from technical writing, presenting to an analytical audience, breaking down complex problems, hypothesis testing, designing experiments, working on complex context-rich domains. During my PhD years, I collaborated with the Federal Aviation Administration and studied everything from display design to air traffic controller training to automation support in the airspace. My dissertation was in fact focused on understanding how different types of automation in the airspace impacted the performance and the situation awareness and the workload of air traffic controllers. During grad school, I also interned with Dr. Micah Ensley, who is considered one of the leading voices on situation awareness, and I had the opportunity to develop situation awareness training programs for the US Marine Corps and hazmat teams. In short, I have to say that during this time, I studied all the concepts of trust in automation, system reliability, meaningful human control, all of which we hear even today in the context of AI ethics. That, I would say, was my introduction to responsible product development. Now, after graduation, I started working at Medtronic, one of the leading medical device manufacturers in the world in the cardiac rhythm and disease management business as a scientist. Later on, I also spent time consulting for several pharmaceutical and medical device companies. Now, throughout this while, I focused very much on the human factor. In other words, how do you design medical devices that are safe and effective for end users? This development process very much involved combining analytical approaches like your failure modes, effects analysis, with more empirical approaches like qualitative and quantitative studies with actual humans to make sure that the residual risk is as low as possible. My time spent in the healthcare space was very rewarding, I have to say, where I got to work on several life-changing and life-saving devices. Fast forward to today, I work on the Ethics and Society team at Microsoft where I lead research. We are embedded within an engineering organization in the cloud and AI business, and I work on several AI and emerging technologies such as computer vision, intelligent agents, mixed reality, synthetic speech, large language models, you name it. My work at Microsoft predominantly focuses on bringing the voices of the impacted community, including traditionally disempowered communities, to help shape AI experiences. I work on a wide range of technologies and therefore tackle a wide range of topics from privacy and consent, fairness and bias, inclusion, meaningful human control, accountability, etc. Let me give you a few examples. Last year, Microsoft released a new service called Custom Neural Voice. This is a text-to-speech feature that allows you to build a highly natural-sounding voice by providing your audio samples as training data. In fact, you only need 500 to 1,000 utterances to create a realistic and natural-sounding voice. It was very important for us to acknowledge that the voice acting industry is directly impacted by this technology. So we brought in the perspectives of voice actors. So we interviewed them to understand their perceptions towards this technology. And they expressed a desire for transparency and clarity about what their voice likeness could be used for with this kind of technology, for how long, the impact to future recording opportunities, and so forth. These were reflected in the terms and conditions of use of the technology. So custom neural voice customers must actually obtain explicit written permission to use a voice actor's voice to create a voice font and provide them with a disclosure. Let me give you another example. A few years ago, we worked on touchless access control, which is a facial recognition based building access system. This technology can do identity verification using your face data. So we asked ourselves a question: what do people need in order to feel safe if the technology were to be deployed at their workplace? Through iterative design and testing with representative users, including people with visual impairments, mobility impairments, as well as individuals belonging to racial minority groups, we designed an enrollment experience that people actually felt good about. And we did that by prioritizing 4 main aspects of consent: awareness, understanding, freedom of choice, and giving that control of data to the users. Let me walk you through another example. Last year, we previewed Dynamics 365 Connected Spaces, which uses data from video cameras to help retailers improve store efficiency and provide exceptional customer service. Now, because Connected Spaces uses cameras to make inferences about the physical environment, we needed to be especially thoughtful in how we would protect the privacy of both shoppers and employees who might be captured in the video footage. So we designed Connected Spaces to preserve the anonymity of individuals as much as possible by focusing on movement patterns and locations rather than actually identifying individuals or even their facial characteristics. We also wanted to make sure that shoppers and employees can actually understand in a meaningful way how the system works and what observations are being captured by the cameras and how might these observations be used. So we invested significant time to understand people's questions about the technology and the privacy protections in place. We then use these insights to create a disclosure strategy for store employees as well as shoppers. Lastly, I work on quite a bit of fairness and representation problems as well, such as how do we systematically design avatars or design data sets, be it face data sets or speech data sets, that actually accounts for the spectrum of human diversity. Depending on the technology, diversity, as you can imagine, can be anything from skin pigmentation to speech patterns to hairstyles. So never a dull day. I think diversity across various parameters like age, gender, ancestry, socioeconomic status, all of these matter because diverse teams bring in diverse perspectives. They address the needs of a wide range of people, they challenge dominant views, and they bring about more innovation. And studies, in fact, have shown that as well, that companies with employees and leaders who are diverse across traits like gender, ethnicity, and cross-cultural experiences are 70% likelier to report capturing new markets. So if you want to create products that work for lots and lots of people, you should care about diversity. I want to touch on 2 aspects of diversity that I'm personally passionate about and perhaps not spoken about as much. One is diversity in disciplines. I believe that that should not be compromised. Engineers and AI scientists cannot solve problems on their own because you're no longer solving problems. You're no longer solving just technical problems. You are solving socio-technical problems. For example, let's say you want to create an automatic speech recognition system that works well for different kinds of English speakers. To do this well, one needs to think through the composition of the training data that accounts for different kinds of speakers, because there is no one way of speaking in English. So how do we go about doing that? This requires an understanding of speech and linguistic variations, factors that impact these variations, from the age the language, in this case English, was acquired, to one's education level, to speech impediments, to name a few. The next step is really prioritizing this understanding and creating a data collection strategy that works for majority of the speakers. This is not an easy thing to do, and no one discipline, let me tell you, can do this well. Multidisciplinary teams involving social scientists, data scientists, engineers, project managers, legal experts, they're all important. In some situations, we have even brought in external experts like biological anthropologists, sociolinguists, and military ethicists to help us in novel problem spaces. So diversity can even extend beyond your immediate team composition to external partnerships with specialists, with domain experts, and with civil society actors. Now, the second kind of diversity that I would like to emphasize is including a diverse pool of end users and other impacted stakeholders as part of your product development process. This means including those whose perspectives are typically excluded or forgotten, such as those from LGBTQ plus community, racial minorities, those whose jobs are impacted by AI, those with speech and visual impairments, bystanders, to name a few. One, I would say to not let the AI technical jargon overwhelm you if you're not familiar with concepts like machine learning, deep learning, etc. There are many ways to learn and contribute as you begin your journey. Two, depending on your area, whatever that might be, demonstrate thought leadership through talks, blogs, and publications. The so-called tech bros are more likely to listen to the voices of a publicly recognized expert in the field. Three, form a solid network of peers that you can leverage for career opportunities, for mentorship, and for constant learning. Lastly, I would say that it's important to realize that changing conventional ways of thinking and doing things, conventional ways of developing technology, that engineering culture, changing that takes time. So be patient, work hard, enjoy the journey. Thank you very much.